Lesson 5-2, Adding and Subtracting Fractions. The main idea of this lesson is to be able to add and subtract fractions with like and unlike denominators. So that means we're going to add and subtract fractions that have denominators that are the same, and we're also going to add and subtract fractions where the denominators aren't the same. Here's our first example. 5/9 plus 2/9. I put these two squares down here because what I'm actually going to do is I'm going to represent each one of these fractions as part of this square, because if this is a whole, 5/9 is just part of this square and 2/9 is just part of this whole square over here, because these two fractions, 5/9 and 2/9, are less than a whole. They're both less than 1, so that means they're going to be represented by less than part of this square. So the first thing that we know is the denominator, the 9ths part down here in both of these fractions, tells us how many pieces each one of these squares is divided into. And they're divided into 9ths. So what I'm going to do is I'm going to divide them into 9ths. And since I'm drawing these out without a ruler, they're just estimates. So there we have 9, because it's 1, 2, 3 going this way, and 1, 2, 3 going this way. And 3 times 3 is 9. So there's 9 little squares inside there. And same thing over here. There we go. So 5/9 means that we color in 5 of these squares. 1, 2, 3, 4, 5. So there's the 5/9. And over here we have 2/9. So we're going to color in 2 of these squares because that's how much we have. And since we have the same denominator, both of these pieces are the same size. That means we can just put them together and we can count up how many little 9th squares do we have in all. We have 1, 2, 3, 4, 5, 6, 7. We have 7 pieces that are cut into 9ths. In all. And without having to draw the picture, what you do is since the denominator is the same, you just bring the denominator across and you add together 5 plus 2 equals 7, which is the same thing that we have down here in this picture. So when the denominator is the same, you bring the denominator across and you add the numerators together. Here's another one. This time we're going to be subtracting. So, and notice that they're both tenths, so that means I'm going to take my square over here and divide it into tenths. There I have 1, 2, 3, 4, 5 pieces going that way, and now if I cut them all in half, I get tenths. So that means our first fraction is that we have 9 of these. So that means we have all of those 9/10. But you end up taking one of these tenths away. So that means this one right here, this 1/10, it doesn't exist anymore. You gave it away. How many tenths do we have left? 1, 2, 3, 4, 5, 6, 7, 8. We end up having 8 pieces that are cut into tenths left over. And if we wanted to simplify that, we could also say that that is equal to 4/5, because 2 goes into both of those numbers. 2 goes into 10 twice. We get 5. 2 goes into 8 twice, and we get 4. So see how we subtracted? I drew out 9/10 and then I took one of those tenths away and I looked to see how many I had left in the end. Since the denominator is the same, the denominator just ends up coming across, and then you just go 9 minus 1 equals 8. So then you don't have to draw out this picture every single time. So when the denominators are the same, when you add and subtract, you just bring the denominator across and then you add or subtract the numerators. So in this example we did 9 minus 1, and in the last example we did 5 plus 2 to get 7. So that's how you work with fractions that have the same denominators. You just bring the denominators across and then you add or subtract the numerators. Here we have 1/2, so I'm going to take this square and I'm going to divide it into half, and that means if I have one of these, that means that I have this much over here. And if I were to have 1/6, there I've divided that square into 6, and if you have one of them, it's going to look like that. Well, here's our problem. We can't just put these things together. These pieces aren't the same size. I mean, look how big this piece is over here, the half, compared to the 6. They're not the same size pieces. So what you have to do first is you have to figure out what the common denominator is going to be. In other words, what's the common number that you can cut both of these into? And what you do is you look at these two numbers and think to yourself, okay, what's a number that both 2 and 6 can go into? And a little hint, it's got to be at least as big as the 6, if not bigger. So what's a number that can go into both 2 and 6? Well, 6 happens to be a number that both 2 and 6 can go into. So that means I'm lucky and I don't have to do anything to this first fraction. Now, a lot of people get hung up with common denominators and they think they always have to come up with the least common denominator. In other words, the smallest number that both 2 and 6 go into. It doesn't matter. You just need to find some number that both 2 and 6 go into. If you don't find the smallest one, that's fine. You're just going to have to do some more simplifying and your numbers will be a little bigger, but you'll get the right answer in the end. So, back to this. I take a look at this. I look at the 2 and the 6. I have to find a number as big as the 6 or bigger that both 2 and 6 can go into. And as I mentioned earlier, that's 6. So that means my first fraction here, I'm not going to do anything to. I'm just going to bring it right down. And I'm going to bring the addition sign down. Now I have to change this 1/2 fraction, so it's going to have the denominator of 6. So I'm going to change the denominator to be 6, but I'm going to go back and I'm going to ask myself, 2 times what gets me 6? Oh, 2 times 3 gets you 6. So that means whatever I multiply the denominator by, I also have to multiply the numerator by. So since I multiplied this by 3, I'm going to have to multiply this up here by 3, and I get 3/6. And if you look at these two fractions, 1/2 and 3/6, they're the same number. So now that we have changed 1/2 into 3/6, and those are equivalent fractions, they're equal to each other, now you can just go back and you can add these two fractions together. And remember, from this previous example, now that they have the same denominator, remember you don't add the denominators together. So that means we're not going to divide the we're not going to add the 2 6's together here. I'm just going to write 6 down. And you're actually going to add the 2 numerators together. So I'm going to add the 3 plus 1, which ends up being 4. And I look at the fraction 4/6 and I think, oh, well, it's not in simplest form because 2 can go into both 4 and 6. So that means 2 goes into 4 twice, and 2 goes into 6 3 times, and there's my answer, 2/3. 1/2 plus 1/6 is equal to 2/3. So I changed my denominators so that they were the same, and I figured out a common denominator. And whatever I had to multiply the denominator by, I also multiplied the numerator by to make my new fraction. I didn't add my denominators together, but I did add the numerators together to get my answer, and then I simplified my answer. So let's take a look at a subtraction problem. Again, we're going to have the same problem as we did back here in this last example, that the denominators aren't the same, so if I were to divide the squares into what these fractions represent, the pieces aren't going to be the same. So I take a look at this and I think to myself, I need to find a common denominator. That means I need to find a number that both 9 and 3 can go into, and it's got to be at least as big as 9 or bigger. Well, I know that 3 can go into 9. So that means I don't have to do anything to this first fraction if I'm going to have the common denominator be 9ths. So I'm just going to write this one down. It's going to stay as 8/9 minus, I'm going to change this new fraction so that it has a denominator of 9. But now I have to ask myself, 3 times what gets you 9? 3 times 3 gets you 9. So that means if I'm going to multiply the denominator by 3, I also have to multiply the numerator by 3. Sometimes students like to write over here on the side that they're going to multiply by 3, just to remind themselves. And 2 times 3 is 6. Now that I have the common denominator, remember you're not going to subtract the denominator, so the denominator for this answer is going to be 9. Now I just have to figure out what's 8 minus 6. 8 minus 6 is 2. And I know that this fraction is in its simplest form because there aren't any numbers that go into both 2 and 9. The only numbers that go into 2 are 2 and 1, and those numbers don't go into 9. So that means this fraction's in simplest form. So there you go. That's how you add and subtract fractions with like and unlike denominators. If the denominators are the same, you just bring the denominator across, and then you either add or subtract the numerators. If the denominators aren't the same, you need to change them so that the denominators are the same, and then you bring the denominator across, and then you add or subtract the numerators. And that's all there is to adding and subtracting fractions.